So this is an airplane here. Okay? So you probably already knew that. If you've flown in one, or maybe you've just seen them fly. But even if you've seen them or been in one, do you know how they work? Is it magic?
Wingardium Leviosa.
Are there invisible fairies that hold the plane aloft?
All right, men, we've got a busy morning and lots of flights to carry.
Or is it science? Well, you can guess that the answer is indeed science.
That's ridiculous.
What?
So to discuss how an airplane flies, we first have to talk about the forces on an airplane, which push it around in all sorts of different directions. Now, we're going to focus on airplanes today because they're awesome, but most of these forces apply to any other vehicle. The first force acts on all of these vehicles. Really, it acts on everything. It's the weight force, which points down towards the center of Earth. Weight is equal to the mass of the airplane, m right here, times the acceleration due to gravity. Here on Earth, g is equal to 9.81 meters per second squared. Now, that's only for Earth. The acceleration due to gravity really depends on the mass of the planet that you're on. The larger the planet, the higher the gravity. So 9.81 meters per second squared here on Earth. The moon, however, it's smaller than Earth, so the acceleration due to gravity is only 1/6 that on Earth, so 1.6 meters per second squared. This is why astronauts can bounce high on the moon, but not on Earth.
This isn't nearly as much fun.
Obviously, there has to be another force opposing the weight and pushing the airplane up. This force is called lift. Lift operates perpendicular to the airplane's wings, which are right here in this side view. Now, if these are only two forces, our aircraft will be able to go up and down, but it won't go anywhere. So we have to have a force that pushes the airplane forward, and this is called thrust. All vehicles have thrust, otherwise they wouldn't go anywhere like our airplane.
Why didn't you buy a car with thrust?
I'm sorry, we can at least roll down the hill.
On an aircraft, this thrust is produced by engines. There are two main types of engines. We have propellers, like this little guy right here, and jet engines, like our first model. Whatever the type of engines, they all work by the same principle. So if we draw a little side view of an engine here, the engines accelerate air out the back, this direction, and by Newton's third law, there's an equal and opposite reaction, and that's the thrust force pushing the aircraft forward. This is really the same thing that happens when you blow up a balloon and you let it go. The air comes out the back and the balloon moves forward. We have a force that opposes the thrust. It's called drag. It points opposite the direction of flight. The major type of drag is pressure drag, which is the force caused by the air smacking into the airplane. So we try to minimize this type of drag by making the airplane as aerodynamic as possible. That means that it has smooth lines and the air flows nice and cleanly over the front here. You can feel the pressure drag when you stick your hand out the window of a moving car. Honey, your hand please. When your hand is horizontal, it's aerodynamic, and you really don't feel a lot of drag. But if you slowly turn your hand vertical, you can really feel the drag increasing. So these are our four forces on the airplane. But perhaps you're thinking,
so this is really cool and everything, but how do we increase and decrease the airplane's lift to move up and down?
That's a great question. Let's look at the equation for the magnitude of lift per unit wing area. We'll call that L. L equals 1/2 times rho times CL times V squared. It's that simple. Okay, I'll tell you what each of these things mean. So rho, it's not a P, it's the Greek letter rho. Rho is the density of the air, which is a measure of the number of air molecules in a certain volume. Density of the air varies with altitude and temperature. So as you go higher up, the air is thinner, and so the density is lower. If we want to simplify things, we generally use the standard density, which is 1.2754 kilograms per meters cubed. V here is the speed of the aircraft, or how fast it's traveling. And CL is something called the coefficient of lift. It's a number that gives us some information about the shape of the aircraft's wings. These things right here. The coefficient of lift changes with the angle of attack.
Angle of what?
Aircraft can pitch up and down. And even if they're pitched up, they're still traveling in a horizontal direction like that. Now, the angle formed here by the horizontal direction of travel and the direction of the aircraft's nose is called the angle of attack. And we denote that with the Greek letter alpha. So we can make a little plot here of that. We're going to put coefficient of lift up on the y-axis and the angle of attack down on the x-axis. So as the airplane starts to pitch up, if I can get a little hand here, thank you. As the aircraft starts to pitch up, the coefficient of lift increases. This is a good thing because we have more lift. As we continue to increase, we eventually reach a point where we keep pitching up, but the lift starts decreasing. This is something called stall, and it's not a good thing. So we generally avoid trying to pitching up this much.
There's a similar equation for the drag per unit wing area, D.
D equals 1/2 rho, not CL, that really wouldn't make any sense, CD. As you can guess, it's the coefficient of drag times the velocity squared. The coefficient of drag it's another number that tells us something about the wings, and it also varies with the angle of attack. So as the angle of attack increases, oh, thank you, the coefficient of drag increases as well. Thank you very much. This is because as the aircraft is pitching up, there is more wing area perpendicular to the flow. Now, this reminds me of something that we talked about earlier. Exactly. This is very similar to whenever you hold your hand out the window of a car. And so, that's pretty much everything you need to know about how an aircraft flies. So the next time you're on an airplane or you just see one, you can really know exactly what it is that's keeping it up in the air. Nope. No, it's not them either. There you go. Now you got it.